Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugwabela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 10. It says a learner sets up the circuit below to investigate the relationship between current and potential difference across the ends of a conductor. She closes the switch and records the ammeter and voltmeter readings. She repeats the experiment 3 times. Each time, she increases the number of cells in the circuit. Then she reads and records the ammeter and voltmeter reading. Then a graph of her results is shown below. Then 10.1.1 says, which physical quantity does the gradient of the graph represent? Now, I always made you note that you have to be very careful of the kind of graph that they will give you. If it's a current versus voltage or potential difference graph, then you have to know that the gradient here will represent the inverse of the resistance, because now if you have to check here, you will have your change in current over your change in voltage. But then if you are looking at I over V, remember we are used to the formula being R is equals to V over I. So if you have I over V, that is the same as you have R to the exponent of -1. You have the inverse of the resistance, so which is the same as 1 over R. So once you have your current this side here on the y-axis, and then you have your voltage down here, then that means the gradient will represent the inverse. So 10.1.1, you must say the gradient represents the inverse of the resistance. The inverse of the resistance. But if you had, let's say, your current over here in amperes, you had your potential difference here in voltage, then that means the gradient in here would represent your resistance, right? So your gradient only represents the resistance if you have potential difference on the y-axis and your current on the x-axis. But if it is inverse, then you have your potential difference here and your current there, then you need to say it is representing the inverse of the resistance. So I hope that makes sense. Then 10.1.2 says, use the information from the graph to calculate the resistance of the resistor that the learner used in this investigation, right? So now we know to calculate the gradient, you only need 2 consecutive points. So we can take the first 2 consecutive points there, and then we know our gradient will be represented by the change in current over the change in the voltage, right? So our change in current, we're going to say that 0.4 minus 0.2, then over 1.2 minus 0.6. Now, when we calculate this, we end up with what? We end up with 1 over 3, right? And then the 1 over 3, remember the gradient, we said it represents the inverse of the resistance. So the inverse of the resistance is 1 over R. But if we want to calculate if we want to calculate the magnitude of the resistance, then at this point we need to say to the exponent of -1, so that this changes to resistance, and then we now have our resistance being 3 ohm, right? So that's how you were supposed to calculate that. And then let's proceed. So we have 10.2. It says the battery in the circuit below has negligible internal resistance. The resistance of resistor R is unknown. When the switch is closed, the voltmeter reads 15 volts and the ammeter A1 reads 1 ampere, right? Then for 10.2.1, they're saying calculate the current in ammeter A, right? So now we want the current that flows in here. But then remember, we are faced with this situation that we had in the previous question, whereby I said if this current is flowing here, And then at this point, the current now splits. That means we are now in a parallel branch, right? But then this 6 ohm resistor and this other 6 ohm resistor, we can see that they're connected in series, but then they're still within a parallel branch. So what do we do if we have a situation like this? We just add these 2 resistors to form one big resistor. So we'll add the 6 ohm and the 6 ohm, and then it will give us a 12 ohm resistor here. So we have our A1 here, and then this 12 ohm, which now at this point we can say that a combination of these 2 resistors will be in parallel to the 12 ohm resistor over there, right? Now at this point we do know that if A1 is reading a current of 1 ampere, and then these 2 resistors, we say they're connected in parallel, but then they are of the same magnitude, then if we have to consider ratios, that's 12 ohm to 12 ohm, they will end up sharing the same ratio of 1:1, which this ratio will be telling us about the current. If the ratio is 1:1, that means the current that flows in the 12 ohm resistor will obviously have to be the same current that flows down here, right, in this other 12 ohm resistor of the combined resistors of 6 ohm and 6 ohm. So that means at the end of the day, also here we have 1 ampere. But then why are we looking at that? We do know of the current that flows in the series part of the circuit is equal to the total current that flows in the parallel, and then which must be equal to the total current. Remember, we know that if the ammeter is connected closer to the battery, then it is reading the total current, right? But then how can we find that total current? We can find the total current by finding the sum of the current in the parallel branch, right? So if we are saying this is 1 ampere and also this one is 1 ampere, that means the current in the parallel will have to be 2 amperes, right? So would have to be 2 amperes. And then if the current in the parallel part of the circuit is 2 amperes, this means the current totally in ammeter A is also equal to 2 amperes, right? So that's how you were just supposed to go about answering that question. So number 1, you say the current in A1. So this is how you'd solve that. The current in A1 is equal to the current in this combined 12 ohm resistor, which is equal to the I parallel. So that means the I parallel is equals to the current in A1 plus the current in that 12 ohm resistor here. So we have to add the 2, the 1 ampere plus the 1 ampere. It will give us the sum of the 1 in parallel. And then, but since we know that the current, the total current that flows in the parallel circuit is equal to the total current that flows in the series, and then which is equal to the total current of the circuit. So that's 2 amperes. So all that was based on this. All that was based on this. Okay, so now let's proceed. We want 10.2.2. It says calculate the resistance of R. So remember, we already have our total current is 2 amperes, and then we want to calculate the resistance R. We do have our total voltage here because we can say the voltmeter is connected directly to the battery, meaning it is representing the total voltage. So the first thing that we would do, we would first start by calculating the total resistance of the whole circuit. So RT will be equals to the V total over the I total. Now the V total is 15, the current total is 2. So if we say 15 divided by 2, we get 7.5 ohms. And then now, to find this R, remember the R here is connected in series. It is the only resistor that is connected in series. These ones here are in parallel. So let's combine the 6 ohm and the 6 ohm to give us 12 ohm. And then let's calculate the resistance in parallel. So that's 1 over R1 plus 1 over R2. So we say 1 over 12, and then combining this, we have 1 over 12 as well. But then remember, this is 1 over RP. So what do we do? -1, and then to the exponent of -1. our RP is equals to 6 ohms, right? If you punch that into your calculator, but then we do know that the R total can be represented as R parallel plus R series, which the R series is the R that we are looking for. Now, R total is 7.5, R parallel is 6, and then the R series is just R. So that's R is equals to 7.5 minus 6, and then the R is equals to 1.5 ohms, right? Then that's just how you calculate that. So now we have our resistance of resistor R is 1.5 ohms. Then let's proceed to 10.3. So it says the resistor R of unknown resistance is now removed from the circuit. So this is now removed. How will this change? How will this change in the circuit affect the reading of the ammeter? Answer: increase, decrease, or remain the same. Now, the one thing that we know is that if we remove this resistor here, then that means we are decreasing the total resistance of the circuit, right? So removing a resistor in series will obviously cause a decrease in the total resistance. So if we have to explain that, number one, if there is a total, if there is a decrease in the total resistance, according to the relationship, R is inversely proportional to the current, then we know if there is a decrease in resistance, then there must be an increase in the total current, right? So that's what we are being asked about. The ammeter A is representing the current, right? So the ammeter measures the current. So our solution here has to be increase, right? And then now they're asking us to explain. We say according to the formula of Ohm's law, which is R is equals to V over I, we know that R is inversely proportional to current for a constant voltage, right? Now, a decrease in the total resistance will result in an increase in the total current. So that's just how we explain that. So we just say increase, and then that is based on the relationship. So we know that when there is a decrease in the total resistance, then this will lead to an increase in the total current, right? Then let's proceed to 10.4. It says the power rating on an electric stove is 1,500 watts. If the stove is used for 3 hours and 30 minutes, note that 3 hours and 30 minutes. Calculate how much it will cost to use the stove if 1 unit of electricity, 1 kilowatt hour of electricity cost 1 rand 15 cents. Now again, the formula for the cost of electricity's cost is equals to kWh multiplied by the tariff. And then now, the first thing that we need to make sure of is that our power is in kilowatts. So as we can see here, we are given our power in watts. So what's the first thing that we do? Say 1,500, divide that by 1,000, right? But then looking at our hours here, we are given 3 hours, 30 minutes. Remember, when we substitute here, everything must be in hours. So that means we need to convert this 30 minutes here into hours. Now we know converting minutes to hours, we need to divide by 60, because we know that 1 hour is equivalent to 60 minutes. So what is 30 minutes in hours? So that is 30 divided by 60. That means 30 minutes represents 0.5 hours. So that's half an hour. Then that means if we have to write 3 hours and 30 minutes in terms of hours, then there will be 3.5 hours. Then multiply that by the tariff, which is 1 rand 0.15. Now at this point, you say this will be 1.5, and then multiply that by 3.5, then multiply that by 1 rand point 15 cents. So if we multiply everything there, we get our solution as 6 rand point 04. So 6 rand point 04 cents, right? And then that is the cost of electricity. So that's how you were supposed to approach this question for a total of 17 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.